All right, y'all. So 2.4 in college algebra deals with what we call the algebra of functions. So basically, we're going to be doing the four operations. We're going to add them, subtract them, multiply, and divide functions, okay? So let me show you some terminology you're going to see. So say you're given f of x and g of x. So y'all, there's four operations, and this is shorthand for what we're wanting done. So the first one, f plus g of x. So when we see this notation, f plus g of x, they want us to take the f of x function and add to the g of x function. Now remember, when you're adding, all you can do when you add two functions is combine like terms. Okay, you cannot do anything else with this. You can only combine like terms. So second, we got subtraction. F minus g of x. Okay, so that'll be my f function minus my g function. Now the thing on this one, adding's not bad because you can drop parentheses. We can drop parentheses and distribute that subtraction through the second function. So we distribute the subtraction and then combine like terms. And basically that's all you can do with adding and subtracting is basically you can only combine like terms. And remember, when you're combining like terms, you cannot change the way the variables look, okay? All right, y'all, then we get into f times g of x. Now, you might see it as a dot in between, or they could just put fg of x. And if the f and g are by each other, that also means multiplication, okay? But basically, this is our f of x times g of x. This is where you'll use the distributive property, foiling, and things like that. And the last operation will be f divided by g of x. So that'll be my f of x divided by g of x. Now, the only stipulation on here, there's only one number that g of x cannot equal since it's on bottom of that fraction. And we know from doing our domain problems the other day that the bottom of this fraction cannot equal 0. So if we're looking at a domain on one of these, and I got a function down on the bottom of the fraction with a variable, then there might be numbers that I cannot put into that function if it makes it equal 0 down there, okay? So the four operations we're looking at today. So we'll go through their examples. So for number one, they're given f of x equals x squared plus 1 g of x equals, let's see, x minus 2. They want us to find f plus g of x. Hey, y'all, let me say something. My computer's giving me a weird little shutdown message. If I get shut down, stay online and I'll reboot my computer. So I'm not sure what's happening there, okay? But yeah, if we get interrupted, stay online and I'll get back onto Zoom. All right, y'all, so look, f plus g of x. So come down with your f plus g of x. Now, I always start out by putting my functions in parentheses. So we're going to have our f of x, which is x squared plus 1, plus our g of x, which is x minus 2. All right, so remember, the left side's just telling us what we're doing here. Here's my two functions, my f of x plus my g of x, going by the pattern we got up here. Okay, so remember the other day in support, if there wasn't no negatives in front of these parentheses, I can drop the parentheses and keep everything the same. So if I drop the first parentheses, that comes out as an x squared plus 1 because there's no number here to distribute. And then here we treated the plus like a plus 1. And when you multiply it, it's not changing nothing. That's going to become a plus x. And then that's still going to be a
Sir, I think you may be on mute.
All right, can y'all hear me now?
Yes, sir.
Okay. Yeah, I'm not sure what happened on that. I'm gonna have to check and see if there's some kind of scheduled maintenance or something, but I'm glad it left everything like we needed it. So let me get back to our problem. All right, it's making me load my camera up real quick. Oh, y'all, let me try this again. All righty, so y'all should be seeing where we were. So remember, I just dropped these parentheses here, brought everything out. So y'all now remember what we said. Only thing you can do, combine like terms. And y'all, if you notice, the only like terms I had are the 1 and the -2. So I'm just going to keep this in descending order of the highest exponent, which is my x squared. Next, I'm going to put my x, which is a positive 1x. And then my number is 1 minus 2, which will give us what? A -1. Okay, y'all? Nothing else I can do since there's no more like terms. All right, y'all, question on that. All right, so number 2, we're given f of x equals x squared minus 4. G of x equals x minus 2. They want me to find f times g of x. All right, so it looks like they're wanting us to multiply these. Remember, we said up here, f times g of x was our f of x times g of x. So f times g of x. So since I'm multiplying two binomials, I'm going to put both binomials in parentheses and put those parentheses right next to each other. And then I'll put in my x minus 2. Remember, when we got parentheses next to each other, we are implying multiplication on this. And y'all, this is what we did the other night. We're going to FOIL that. So we'll multiply everything, and then once we get done multiplying, we'll add like terms. So y'all, let's see what y'all get on this. How about that x squared times that x? And y'all remember all I'm going to do is add exponents. And since this one don't have an exponent, it's a 1 sitting there. So the
X to the third.
X to the third. And now this one, I got the x squared times -2, which is just a -2x squared. All right, now distribute the -4. -4 times x is a -4x. And then y'all, that -4 times -2, that's going to be a positive. And what 4 times 2 give us? 8. So distribute the first term through the second parentheses. Distribute the second term through the second parentheses. It's like you're doing a double distributive property here. All right, can you go further?
No.
No, because none of those are like terms. Good job. All right. So now let's see. This one we're given f of x equals x squared minus 4. G of X is X minus 3. But y'all want to throw you a curveball. They want us to find G times G of X. Okay, so G times G of X. So it's going to be multiplication again. So I'm going to use my parentheses. But y'all, here's the question. What are you putting in these parentheses? Because look what they want here. They want G times G. Well, G is X minus 3, right? So I'm going to put an X minus 3 here. And y'all, what are we putting here? Well, that's
X.
G times G, so we're putting G again. They didn't use F in this one. They just threw this in here for a curveball, okay? What we got to put in here to multiply is what they're asking for right here. Which means I get to FOIL again. All right, y'all, X times the X squared. This X times negative 3 is a negative 3X. All right, so now we'll distribute this negative 3 here times X. And y'all get another negative 3X. And then finally, that negative 3 times negative 3 is going to give me what? A positive 9. So can you go further on this one? I'm seeing some head shaking, so good job. Because y'all, you got like terms and they do not cancel because they're both negative. So bring down your X squared. Negative 3, give me a negative 6X. And y'all at the end is our plus 9. Okay, so basically, these didn't cancel, they basically doubled because you had 2 of the negative 3x's, okay? All right, so if you notice, they're giving us 2 functions every time and then telling us what they want us to find. Sometimes they use the f and x, and then sometimes, like this one, they did a g times a g. So let me show you the next curveball we're going to get hit with. All right, y'all, so I'm going to turn the page. All right, so it'll start out the same. They're going to let f of x equal a negative 8x plus 11. G of x is going to equal x squared plus 18. But y'all, here's the curveball. They want us to find f of 7 plus g of 7. So look at that. They're giving me numbers to put in for the variables on these functions. Okay? So I don't have just x's here now. I got numbers. So we're going to come over here. F of 7 plus g of 7 will equal our f equation plus our g equation. Now, when I put in my f, remember I got to put in a 7 for that x. So that'll give me negative 8 times 7 plus 11. And then when I put in my g, I got to put in a 7 for it. So that'll give me 7 squared plus 18. Now, y'all, let me tell y'all this. If this G would have been negative, I would have put my -7 in its own parentheses when I got a squaring behind it, okay? So remember, negative numbers, I always put in their own parentheses. So y'all look here, this one, since I got numbers in it, I can actually work inside these parentheses and follow my order of operations. So the first parentheses, you got -8 times 7 plus 11. You got to multiply first. So -8 times 7 will give you -56 plus 11. Second parentheses, you got to exponents before you add. So 7 times 7 is 49 plus my 18. Now notice, each parenthesis only has one operation to do in it. So I'm going to add -56 plus 11. That'll give me a -45. And it can come out of the parentheses now. And over here, I'm adding what I get from these parentheses. Well, 49 plus 18 gives us 67.
67.
And y'all, that's out of the parentheses. And so now I'm down to the final step, which is actually adding. So F of 7 gave me -45. G of 7 gave me 67. Adding them together, looks like I get what, 22, it looks like.
22.
22, there you go.
Positive 22.
And then that'll be our final answer. So remember, these are really controlled by what operation they want, and are they giving me something here other than the X that's in the variables, okay? All right, y'all, so on this one, so questions on those yet? All right, y'all, so this one, I'm going to let F of X equal -13x plus 14. G of X will equal x squared plus 7. They want us to find F of 10 minus G of 10. Now, this one's tricky because you're going to have negatives running everywhere. But I do know they want me to put a 10 in for the x's on both of my functions. So y'all, here we go. F of 10 minus G of 10 is going to equal my F minus my G. Okay, so here we go. My F is -13. But remember, they gave me a number to put in for the X, and they want me to put a 10 in. And then I got plus 14. So there's my F of 10. So now my G of 10 will be x squared. So that'll be 10 squared plus R7. And y'all, once again, I'm going to work my order of operations inside each parentheses. Was there a question?
No, I'm sorry. I just it just clicked.
Okay, you're good. All right, y'all. So multiplying and adding, you got to multiply first. So -13 and 10 gives me a -130 plus my 14. Over here, I got to do the exponent before I add. So 10 times 10 gives me a 100 plus my 7. All right, so notice the only thing I can do in either of my parentheses is adding. So let's add this -130 plus 14. That'll give us a -130. 16. That's going to be minus what I get out of my second parentheses. Well, that's just 100 plus 7, which will give us a 107. So y'all look at this. I got a negative 116 minus 107. So this is like I'm adding two negatives. So that answer will be negative. And y'all, what is that? A 223. Okay. So remember, work inside the parentheses. Your last step will be the subtraction, okay? When you got a function minus a function, that's the last step, is that subtraction. Now, I'm not going to lie. At this point, you could have thrown that in your calculator, and it would have spit it out quick. So let me show you. Let me pull my calculator up. All right, so I'm going to share the calculator. So at that point, when I had my parentheses, negative 13 times 10. So I'm going to use some parentheses for the multiplying there. And then it was plus 14. Close parentheses minus the second parentheses, which was a 10 squared, plus 7. And then I can close those parentheses. So hopefully we end up with our negative 223. Okay. So any of those where they give you numbers to put in, they can be done on your calculators, okay? All right, y'all. So let me do one like this one. How about what's this one look like? Multiplying. So f of x equals negative 20x plus 18. G of x will equal x squared plus 10. They want us to find f of 2 times g of 2. So a little multiplying here we got to do, it looks like. And they are telling me on my f to put in a 2 and on my g to put in a 2. So f of 2 times g of 2 will equal my f times my g. So let's put a 2 in for the x on f. We get negative 20 times 2 plus 18. Okay, so it looks just like f of x, except we're putting in a 2. Now, g of x was x squared, and I got to put a 2 in for that. So that'll give me a 2 squared plus 10. And y'all, I'm going to do the same thing again. Work inside each parentheses. My last step will be that multiplication. So the first parentheses, got to multiply before I add. Negative 20 times 2 is negative 40 plus 18. Second parentheses, I got to do my exponent before I add. So 2 times 2 is 4 plus my 10. Ooh, y'all, this is going to give me a big number, it looks like. So the last thing I can do in the first parentheses, negative 40 plus 18. Ooh, y'all, that's a negative 22. So that's my first. And I'll just keep them in parentheses since I'm multiplying. And then here, 4 times 4 plus 10 is 14. All right, y'all, so I'm going to have to break up my calculator on that. And so we got a negative 22 times 14.
$308.
So I'm getting a negative 308. Good job. Alrighty, so y'all, that's a trick. They're going to go back and forth putting things in for us to try to replace those variables with. Sometimes they'll give us variables, sometimes they'll give us numbers. All right, this one. Let f of x equal a negative 5x plus 9. G of x, y'all, is going to equal x squared plus 16. They want us to find f of a negative 4 divided by g of a negative 4. Now, I have noticed on all the problems, we're getting the same number for each function to put in, okay? All righty, so looks like we're doing division. So f of negative 4 divided by g of negative 4 will equal my f equation divided by my g equation. And then remember, I'm putting a negative 4 in for each of the x's. So f on top will be negative 5 times negative 4 plus 9. Now, y'all, here's where you got to be extra careful. Since I'm putting in a negative number, negative numbers automatically get their own parentheses. And then square that plus 16. So y'all notice, negative numbers, I always put in parentheses when they got exponents there, okay? All right, y'all. So the top, now if you put this on the calculator, you better put these parentheses around the top and bottom or you will get the wrong answer. Okay? You got to use the extra parentheses. All right, y'all. So on top, negative 5 times negative 4 will give me a 20 plus my 9. On bottom, a negative times a negative is going to make that a positive 16 plus that 16. All right, so I'm getting there.
Is that because the negative is inside the parentheses?
Yes. And anytime you throw a negative number in for a variable, you got to square that negative. So any number you square will become positive, okay? All right, now add the top, add the bottom. Looks like I'm getting a 29 on top. 16 and 16 give me 32 on the bottom. And y'all, I don't think that's going to reduce, but if you want to check and see if it reduces, pop it on the calculator real quick. So I had 29 divided by 32. Now this will give me a decimal, but I'm going to tell the calculator to turn the decimal back into a fraction by hitting math and enter twice. So y'all kept it at 2932. That means that that fraction does not reduce.
I have a question.
I hear you.
When we put our answers in, will it ask for a whole number? I mean, ask for like fraction and whole number? Well, we can't do that.
It'll tell you to type an integer or a simplified fraction.
Okay. Thank
But
you.
you don't have to worry about doing mixed numbers or any of that stuff.
Oh, okay.
So if your number's like 17 over 2, leave it 17 over 2. Okay.
Oh, yeah, because that wasn't like that. Okay.
All righty. So let me get my paper turned here. All righty, y'all. So now, so those were the few where they hit us with the numbers. So now they're giving me f of x is going to equal negative 2x plus 3. G of x is going to equal x squared plus 2. On this one, they just want me to find f plus g of x. So notice no numbers here. So y'all let me see what my chat's saying. Hang on and I'll look. So I see your name going up. All right, I had to answer chat real quick. All right, y'all. So f plus g of x. That's going to equal my f equation plus my g equation. F is a negative 2x plus 3. G is an x squared plus 2. Now remember, we're adding these. So we can drop these parentheses and everybody's sign stays the same. Okay, so we bring down to negative 2x plus 3. And then bring down to x squared. And it stays positive. And then the 2 stays positive. Remember, they're following addition. So we treat it as positive ones getting multiplied. Now, at this point, I'm going to add like terms and put mine in descending order. So the highest exponent is the x squared. So I'm going to bring it down first. Next, I would put that negative 2x. But then I got like terms on the numbers. I got a positive 3, positive 2. That's going to give us a positive 5. And y'all, no more like terms. So final answer. So are you noticing? If I give you numbers here, it's worked all the way down to a single number. But if I give you a variable here, all you can do is break it down to like terms. Okay? All right, y'all. They want me to find f minus g of x when f of x equals 9x minus 5 and g of x equals 3x minus 8. So this one is subtraction, f minus g of x. So I remember I got to distribute my subtraction first when I get rid of the parentheses and then combine like terms. So f minus g of x will equal our f minus our g. And notice, once again, they didn't give me no numbers. So f of x will stay 9x minus 5. G of x will be the 3x minus 8. But y'all, the most important step is what we're about to do. First parentheses has nothing in front of it, so I'm going to bring down that 9x minus 5. So y'all, who wants to guess at the next two terms we would write here? Based on that support stuff.
Negative 3x plus 8.
Negative 3x. Perfect. And then negative, negative, made that a plus 8. Good job. Oh, and y'all look at this. I got all kinds of like terms. This 9x and that negative 3x, they're like terms. So that'll just give me a 6x. This negative 5 and positive 8, they're like terms. And 8 minus 5 just gives me what? A positive 3. Okay, y'all. So notice I had variables. They didn't give me numbers. So the variable stayed again, okay? So let me throw a twist in this now. What if I let f of x equal a negative 4x plus 5, g of x equal x squared minus 5. But y'all, this time, let's say I want to find g minus f of x. So we know we're going to find g minus f of x. So subtraction, I'm going to put everything in parentheses and subtract. But y'all, here's the question. What's going in the first parentheses and what's going in the second? So y'all start me with the first one. What are y'all putting in this first parentheses?
X to the second minus 5.
Perfect. I was wanting to make sure y'all caught on to that reversed order there.
Mhm.
Good job. And then I guess my f is going in here, which is what? A negative 4x plus 5. All right, y'all. Same thing I did here, we're doing here. Drop the first parentheses. So you get an x squared minus 5. All right, y'all, finish me out. 2 more terms.
Positive 4x,
Positive 4x, perfect.
negative
And
5.
negative 5. Okay, so remember, subtraction is the only one we got to worry about at this point. So what's y'all's final answer?
X x squared plus 4 squared minus 10.
Oh, you're so perfect. But what was behind this 4 you said? You said squared, but I think you just meant the x.
4x. I mean, negative. I mean, x squared plus 4x
Uh-huh. Because remember,
minus
4x didn't have no like terms, so we just brought it down.
right, and then
Uh-huh.
minus 10.
Uh-huh. Perfect. Negative 5, negative 5, negative 10. Good job.
Ooh, jeez.
Oh, they get tricky. All right, so they like to ride this subtraction a little bit. So this one has a f of x equals x squared minus 11. G of x equals 9 minus x. They want us to find f minus g of 8. But notice how they're doing different lingo here. While ago they said find f of 8 minus g of 8. They want you to realize that f minus g of 8 is the same thing. You're putting the 8 into every variable there, okay? So just different ways to write the same lingo here. F minus g of x. Earlier we had f of something plus g of something. So they're just showing you different ways to see this. But we're going to find f minus g of 8. That's going to equal our f
Oh,
minus our g. And in place of every x, you're putting a 8.
8. Oh, okay.
Right? So this will actually be f of 8, which will be 8 squared minus 11. And this will be g of 8, which will be 9 minus 8. Okay? So different ways to let you know that this number is going into every x that you see, okay? All right, y'all. So here, 8 squared is what, 8 times 8. Oh, that's like what, 64 minus 11 minus this parentheses. Well, 9 minus 8 is just a 1. All right, so I can finish out these parentheses. 64 minus 11, 53 minus, well, y'all all got here is a 1. So bring down my 1. And then that's going to equal 53 minus 1, which is 52. So notice they're going back and forth. They really want y'all to focus on what are they giving me here, X's or numbers. All right, so watch this. They're going to keep turning it up. So y'all good so far? Just a lot of adding and subtracting and multiplying tonight, okay? So let me throw you another curveball here. What if I did this? Let f of x equal x squared minus 3. But then I said g of x equals 12 minus x. So y'all let me see what my chat's saying. Okay, that sounds good. And then what they want me to find on this one, f times g of a little n. So y'all, let's see what y'all are going to do. F times g of n, so bring that over here. F times g of n. Remember, that's going to equal my f times my g. But y'all, what I'm interested in, what in the world are y'all putting in this first parentheses for your f?
X squared minus
N squared.
Oh, I think I heard it. I think I heard the n squared, right? N squared minus 3. Because now they're saying, hey, wherever you got a variable, you got to put a n. So what's going in the second one?
12 minus N.
12 minus n. There you go. Okay. So this is just to throw y'all a curveball to make sure y'all are paying attention. That since I didn't put an X here, I want you to put that in over here. Okay. All right, y'all, you're multiplying, so we get to FOIL again. Now, this one actually tells you on the answer blank when we're done, they want this in descending order. Highest exponent and keep going down. So, y'all, let's see what we get. N squared times 12 is a 12n squared. How about this? N squared times a negative n.
negative n to the third power.
Negative n to the third. Good job. All right, now we got that negative 3 times 12. What's that? Negative 36. And then you got that negative 3 times that negative n. So that's a negative and a negative. I'll make that a positive 3n. But remember, they will not take this answer like that. It's got to be in descending order from the highest exponent down. So y'all rearrange that. That means this negative n to the third has to go out front. Oh, what's next? The positive 12n squared. All right, y'all going down. My 3n is next. So positive 3n. And then finally will be our negative 36. So when you rearrange them, they still got to have the same sign, okay? So here what we did, we had to put into descending order. So if you did put it in this way and it marked it wrong, look at it. It'll tell you your answer's right, but it's not in the correct format, okay? And then just look under the answer blank and it'll say this about the descending order. All right, y'all. This one I'm going to let f of x equal x squared minus 2. G of x is 14 minus x. They want us to find f divided by g of a 3. And y'all, we've done division earlier. The only difference now, instead of doing f of 3 divided by g of 3, they're using this f divided by g of 3 lingo, okay? So same thing we did earlier, they're just using different lingo. So y'all, f divided by g of 3 will equal our f divided by rg. So y'all, what are y'all putting in on the top of this for your f?
Three squared minus two.
Perfect. And that means on the bottom, we're going to put a 14 minus R3. All right, y'all. So remember, just different lingo, but you're still putting a 3 in for everybody's x's. All right, y'all, let's see on top. 3 squared, 3 times 3 is 9. So that's going to give me 9 minus 2. On bottom, the only thing I got to do is subtract. 14 minus 3 is 11. And y'all, the last step, what's that? 9 minus 2 gives me what? A 7 over 11. That does not reduce, so final answer. Y'all ever heard of a store called 7-Eleven?
Yeah.
It's pretty popular when I was younger, but not too many now. All right, y'all. So these next few problems deal with domain to see what y'all remember about our domain stuff. So what these will say for the pair of functions, determine the domain of the sum, difference, and product of the two functions. Okay, so it's basically almost like 3 problems in one. I got to figure out the domain of my sum if I'm adding them. See what's the difference, the domain for the difference if I'm subtracting them, and what would be my domain for my product if I was multiplying them, okay? So first I'll start with the domain of the sum. Oops, hang on, y'all. Let me give you my functions first. I need to give you f of x and g of x real quick. F of x is an x squared. G of x is a 9x minus 9. All right, so here we go. I'm going to start with the sum first. The sum will be f plus g of x. So that'll equal our f plus our g. Well, f of x was x squared. G of X is 9X minus 9. So y'all, let me ask y'all this. If I gave y'all this problem and I said, hey, what's my domain? What would y'all say?
X to the third.
Well, don't multiply that. Let me remember domain the other day. Domain was all the numbers that I could put into this function and get a real number out of it. Remember? And there was only one thing I was concerned with when I did a domain problem.
3.
Oh, I
All
got
real
you.
numbers if it's not a function.
Oh, say that again.
All real numbers if it's not a fraction.
Do you see a fraction? Do y'all see a fraction here?
No.
No fractions. That means any number I put in for these x's, I can square it, I can multiply by 9, and I can add that stuff together. So our domain is x such that x is a real number. Just because we changing the subject don't mean that we're not worried about. Only thing we're worried about are those fractions, okay? So let's difference. Well, the difference will be f minus g of x. That'll equal my f minus my g. Well, y'all, f is still x squared, and g is 9x minus 9. So what we want to know is, what's the domain for this subtraction?
I have a question. Why did we change it again? Why did we change the from adding to subtraction?
Oh, no. Y'all, I'm not, this is a separate problem now, because remember right here, they said, hey, determine
Oh,
the domain of each of those, okay? So we figured our domain for our sum was all real numbers. Now we want to know the domain of this difference.
okay.
Well, hell, y'all, I
All
still
real
don't
numbers.
all real numbers because I still don't see any fractions there, right? So x such that x is a real number. Usually when you're doing domain and you got two functions, adding and subtracting always have the same domain. Even a product, usually, watch this, the product. That'll be f times g of x. That'll equal my f, which is x squared, times my g, which is 9x minus 9. So I got these two functions I'm multiplying. Do you have any restrictions on their domain?
No,
No. So that means our domain,
all real numbers.
all real numbers.
So when we see a problem like that,
Uh-huh.
will it actually, so when it asks for the domain, is it asking us to determine if it's a real number or not?
Yeah. Remember the other day we said that any function that did not include a fraction, I can throw any number I want in here. If I want to throw decimals in here, fractions, negative numbers, positive numbers, I don't have no restrictions because it wasn't a fraction. Now remember, when I deal with the fractions, I'm very concerned with the fractions because if I get a 0 in the bottom of the denominator of a fraction, that makes it undefined. So that means there's a number you can actually put in that gives you something other than a real number, okay? And our domains should only have numbers in them that give us real numbers for the outputs. So let me see. This next one will tell me if y'all got this. Y'all, it's the same thing. we're going to find the domain of the sum, difference, and product. So our f of x this time, f of x is 1 over x minus 5. G of x equals 6x to the third. So let's do them just like we did a while ago. Start with our sum. The sum is f plus g of x. That's going to equal my f plus my g. But f was a 1 over x minus 5. G was a 6x to the third. Can this domain be all real numbers?
No. It's a fraction.
No. And that's because there's a
Fraction.
Fraction.
fraction sitting right here. And there's one number that if you put in for that x, will make that thing equal 0 on the bottom. So we know that this x cannot equal what? Perfect. X cannot equal 5. If you put a 5 in there, that makes that undefined. And undefined can't add to anything. So y'all just be careful, okay? If there is a fraction, the domain will be whatever number makes that 0. So this will be x such that x is a real number. And x cannot equal 5. 5 is the only number that'll make that equal 0, which will make it undefined, okay? So now you got your difference. F minus g of x will equal my f minus my g. So y'all, 1 over x minus 5 is my f. 6x to the third is my g. So my question for y'all, what is my domain? Well, can this be, can that be all real numbers?
No.
No. So it's going to be what? X such that x is a real number. And y'all, x cannot equal what?
5.
5. So look at that. Adding and subtracting still have the same domain, don't they? So let's see what happens with our product. That'll be f times g of x, which will equal my f 1 over x minus 5 times my g 6x to the third. What do y'all think that domain is?
Not a real number.
Well, what's hurting you is this fraction again, right?
Yes.
So what's the only x value you can put in there to give me an undefined number? 5 again, right? So good job. I can't do a 5. So remember, on all of these, the way they're set up, x cannot equal 5 because that gives you an undefined fraction. So I want y'all to notice adding, subtracting, multiplying, always got the same domain, okay? So X is a real number. And X cannot equal 5. So when you're doing number 14 and 15 and you figure out the domain of the sum, you might as well repeat that 2 more times, okay? All right, y'all. So adding, subtracting, multiplying. Well, there's one operation left, and that's to find the domain of a quotient. So what they want me to do for F and G, determine the domain of F divided by G. So F of X is going to equal 7X minus 10. G of X is going to equal 10X minus 30. So it's a domain question again. So remember, F divided by G of X will equal my F divided by my G. So y'all on top, my F is at 7X minus 10. On bottom, my G is a 10X minus 30. So I want the domain. Is this domain all real numbers? No, good job, because we got a big fraction here. So what you got to do is solve that bottom and tell me what X value makes this equal 0. And y'all, that's when you was over here. Set that 10X minus 30 equal to 0 and solve that. Just like we did the other day. You're going to add 30. So let's see, 10X will equal 30. Divide both sides by 10. So X equals 3 when I solve that, which means if I put a 3 in here, this thing's giving me a 0, which is undefined. So my domain will be all X's such that X is a real number and X cannot equal that 3. Okay. Now, any other number you want to give me, you can put in for these X's and it'll give you a decimal fraction or negative number, positive number, but it'll give you something, okay? You just can't put a 3 into that. So y'all, this was this exercise today. Getting you up to date on your foiling, adding like terms. If I give you a number in there for an X, are you able to plug it in there and solve it using your order of operations? Okay, so that's going to be the main thing is those 4 operations for y'all tonight, okay? All right, y'all, so hit me up with your questions. Questions over this 2.4. All right, so y'all, let me quit my recording here.